Hi, this is Lance from LangChain. Anthropic recently put out this blog post called Building Effective Agents, where they define what an agent is and also explain what a workflow is. So I'm going to build every workflow and agent that they talk about in this blog post from scratch and explain what they all are, how to build them, and why each one can be very useful. So here's a simple way to think about their definition of a workflow versus an agent. Think about a workflow as some kind of scaffolding of predefined code paths around LLM calls. Now, this has been popular for years, and it makes a lot of sense in many cases to take LLM calls and embed them in some fixed set of code paths. Now, sometimes you can actually have the LLM decide what paths to take in a workflow, and that's kind of this middle category that I drew here. And we'll talk about all these in detail. But that's kind of the intuition. Workflows are kind of like some scaffolding of predefined code paths, and you can embed LLM calls within it. Now, agents remove the scaffolding. So you're basically letting an LLM direct its own actions. Now, in this particular case, actions are typically tool calls, and an LLM will receive the feedback from those tool calls and decide what to do next. I do want to call out that you can certainly have LLMs that perform tool calls within workflows, but the difference is that workflows have some scaffolding around them, whereas an agent is unbounded. So an agent just directly receives the output of environmental feedback from tool calls, decides what to do next, without the kind of reasoning scaffolding around it. So that's really the differentiation. Now, just before I get started here, it's important to call out why frameworks, okay? So implementing these patterns doesn't require a framework, right? Sometimes this can be done in a few lines of code. I completely understand that. So you might say, okay, well, why are you talking about this? Why are you trying to promote frameworks? Here's kind of my take on it. LangGraph really aims to minimize the overhead of implementing these patterns, okay? It doesn't abstract prompts. It doesn't abstract architecture. What's really happening with LangGraph is it's supporting infrastructure underneath any workflow or agent. That's the key point. And really, it's three things. One is persistence. This gives you memory. This gives you human in the loops, the ability to pause, for example, while an agent is processing, and approve a tool call. Pause and review what the agent's doing. This is extremely useful in many cases. Streaming. So of course, LLM APIs stream tokens. We all know that. But when you build these workflows or agents, sometimes you want to stream, for example, what certain steps output. You might want to stream the outputs of tool calls. You often want more flexibility over streaming than just what the LLM calls produce. And so LangGraph gives you a lot of control over what you're outputting from your workflow or agent. And this is very useful when actually building these and putting them in production. And the third is deployment. So testing, debugging, and deploying. That is a big benefit of using LangGraph. It is extremely easy to go from any workflow or agent you implement to a deployment. LangGraph doesn't abstract prompts, and it does not abstract architecture. It's really giving you low-level infrastructure that sits underneath any of these workflows or agents. So now we've laid the foundations, let's talk through the various patterns laid out in the blog post. First, starting with the augmented LLM. LLMs can be augmented with many different things. One is, for example, memory. We talked a little bit about that. That's one of the things that a framework such as LangGraph can provide. Also, LLMs can interact with tools, and this is the foundation for building many workflows and agents. So let's build this from scratch. So here's my notebook. I've just pip installed a few packages, set my Anthropic API key, create my LLM. Now let's show the augmentation for structured output. I can take a schema, in this case a Pydantic model. I can bind it to my LLM. In this particular case, I'm using LangChain, and I'm going to use the with structured output method in LangChain to do this. But again, LangGraph does not require you to use LangChain. You can use the raw model API, so it's completely fine. I run that, and the output adheres to my schema, which I passed here. So that's great. Now let's do the same with tool calling. I'm going to take a tool. I'm going to basically define this function multiply as a tool that the LLM has access to. I can use the bind tools method in LangChain to bind it to my LLM. Now I have an LLM with tools. I invoke it with an input that's likely to elicit the tool call, and I get the output. Great. You can see a tool call is produced. It takes this input and creates the arguments necessary to actually run this function. That's it. Remember, when LLMs are creating tool calls, they're really just giving you payloads to actually run that tool. You could then run the tool, pass the output of the tool back to the LLM, and really doing that loop gives you an agent like we saw before. We've talked about Augmented LLM as a core building block. Now let's talk about some of the workflow patterns covered in the blog post, starting with prompt chaining. Here's the intuition. Each LLM call processes the output of the previous one. When do you want to do this? When you have a task that you can decompose into a few different LLM calls. So in this little example they show, there's an input, call 1. You can have some gating on the output of call 1. Output goes to call 2. That output goes to call 3. So let's basically build this from scratch, and let's do an example where we build a chain that takes a topic from a user. The LLM makes a joke. We check to make sure the joke has a punchline, and we improve it twice with 2 subsequent LLM calls. Now, when I'm working in LangGraph, all I need to do is basically define a container for everything that I want to modify over my workflow. So in this particular case, I'm just going to create a dict, and it's going to contain topic. That's what we'll get from the user. The joke will be the output of that first call. Improved joke will be the output of the second call. Final joke will be the output of the final call. Now, when laying out workflows, I actually like to draw them out anyway. So this is kind of cool that the blog post has all these laid out. And when you draw these out, think about, for example, each of these calls or steps is just a different function. So for this particular workflow, I'm going to create a function generate joke, improve joke, polish joke. And those are all going to be just simple LLM calls. Now, what's interesting is with LangGraph, this container or state that I define is passed into every one of these steps, and I can extract whatever I want from it. In this case, I go state topic to get the topic that is written to state by the user. And I can write things back to state just by basically returning this joke key, the output of my LLM call. Improve joke, I populate improve joke. Final joke, I populate final joke. So what's happening is, at each of these steps, I'm making LLM calls, and I'm populating my state, or this container, in the workflow with the output of each LLM call. That's really all that's going on. Now notice in this workflow, there's a gate here. So in this case, I'm just going to create some gating logic. So what's interesting is, I can take in the state, and I can just check, hey, does the joke have a question mark or an exclamation point? That's just some arbitrary criteria. And what I can do is I can pass anything I want here, just 2 strings, pass or fail. Now this can be used as conditional edge or gate in LangGraph. So now I have a container that has everything I want to modify in my workflow. I've defined each step in my workflow as an independent function. I've defined a gate that's going to serve as that check on the output of the joke. And now I lay this out in LangGraph as a simple workflow. So all I need to do here is just take in my state, initialize the workflow, add those 3 steps to it. We added generate joke, improve joke, polish joke. And this is where I define the connectivity of my graph or workflow. So I'm going to start. I'm going to go to generate joke first. And you can see then I want to check the output of my first call to see whether or not it has a punchline. So I add a conditional edge that connects generate joke, and based upon the output of this function, if it's pass, I go to improve joke. That's my other node. If it's fail, I just end. Then I create the edges from improve to polish, polish to end, compile that as a workflow, and there we go. So that's the exact same workflow that they drew out in the blog post applied to joke generation. Now, once I have this workflow, I can very simply just run chain.invoke. That's a very simple way to invoke any chain workflow or whatever you have in LangGraph. I pass in a topic from the user, and we can see the LLMs create an initial joke. They improved it, and Claude creates final joke. So this is a very simple example of a chain. Great. So we've covered the augmented LLM. We've covered basic prompt chaining. Now let's get into some more interesting and complex workflows like parallelization. Now let's talk about parallelization. Do this when you, for example, have multiple perspectives that you want for a single task. So I've done this quite a bit with things like multi-query RAG. If I have a question, I want to fan it out into like 3 or 4 different sub-questions. Or when independent tasks can be performed with different prompts or different LLMs. So lots of cases where you want to just parallelize tasks and workflows. So let's just build this. Let's take a topic, create a joke, story, and poem all in parallel. So in the same way I did before, I create my state. Again, this is just a container for everything I'm going to modify in my workflow. In this case, I'll have a topic from a user, and I'll have the joke, the story, the poem, and I'll just combine them at the end. Now, this workflow is going to have 3 LLM calls. They'll run in parallel, and then 1 aggregation that'll pull them all together. So all I'm going to do is I'm going to create a function for each of those different steps in my workflow. LLM call 1 is going to write a joke about the topic, a story, a poem, and I'll just aggregate them all into a string. Super simple. Now, just like I showed before, we can build this in LangGraph. Pass in that state, the container, add the nodes, and just connect them. So in this case, I go from start to LLM call 1, 2, 3, and they all connect to the aggregator in the end. And I can show it. There you go. So you have a nice visualization of your workflow, and I can run it. There we go. So we have a story now, a joke, and a poem, all created in parallel. So we've covered the augmented LLM as our building block. We talked about prompt chaining. We talked about parallelization. Now let's get into routing. I've used routing a lot, and it's extremely useful in a bunch of use cases when you want to decide, for example, if you want to only go to one of those steps, which one to go to, you can use an LLM to make that decision. So a specific example of this is I've used routing a lot in working with retrieval in taking a question and routing it to different retrieval systems. So let's do an example where we take an input and we route it to either a joke, a story, or a poem generation based on what the user asks for. Now I'm going to show a very nice trick here. For routing, I often like to do this. I basically take an LLM and I give it a structured output. So that guarantees the LLM is going to produce, in this particular case, the strings poem, story, or joke as a structured object. And I'm going to give it, in this particular case, a pedantic model. Just like before, I'm going to define my state. Again, this is a container. We'll take an input from the user. We'll get the decision from our router, and we'll get an output. We'll save that as the final output. Now, in this case, for my nodes, just like before, I'm going to have 3 different LLM calls that will either write a story, a joke, or a poem. And I'm going to have my router, which is going to take the user input and basically decide whether or not to route it to story, joke, or poem based upon the content of the input. And it's just going to return that as a structured object. And I can extract from the data model the step decision, write that to state as decision. So remember, if you look at the model here, it's just a pedantic model, which is going to output a single key step, which is either going to be poem, story, or joke. So I extract that from the pedantic model that is returned by the router, and I write that to state. So then I have my decision in state. And now this is just going to be a conditional edge that'll look at the decision and determine what node to go to. Super simple. So basically, if the decision is story, go to node 1, joke 2, poem 3. That's it. Now you'll see in this toy example, each of these steps are doing the same thing. But in real world examples, the router will send to different steps that will have different logic, different LLM calls. This is just a toy example showing you how to hook up that logic between, for example, a router step, a structured output, and a decision about where to go next. Cool. So this is showing you visualization of that. Now you'll see what's kind of nice in LangGraph. When we visualize this dotted line means a conditional edge. So it's going to go to only one of those 3 paths whenever this runs. And of course, that's going to be based upon the decision of the router. Now we can look at these nodes and just create a print statement that'll just tell us which node was visited to confirm. We can run this. Cool. So we know we go to the node that creates a joke and we get the joke output. We've covered the augmented LLM as our building block. We talked about prompt chaining. We talked about parallelization. We talked about routing. Now let's talk about another workflow, Orchestrator-Worker. Now this is a really interesting one, and I've used this quite a bit as well. So this is a case where you want an LLM to break down a task into a set of subtasks, delegate each subtask to an independent worker, and then synthesize the results. So it's kind of like parallelization, except the key difference is this worker assignment, you don't know ahead of time. So you're having an LLM reason about something and then create a bunch of workers based upon its reasoning. So again, in this case, the LLM is kind of gating or creating the control flow, just like in the case of routing. So here's an example that I've used quite a bit. Report writing. Maybe you've played with deep research. An LLM reasons about the plan for the report and dynamically generates a bunch of report sections and then goes and does research on all of them. Classic example of an orchestrator-worker type workflow. So let's actually do that right now. So for this, the trick is I'm also going to use structured outputs. So I'm going to create a data model for a report section. It's going to have a name and a description, and I'm going to have a list of sections here. So what I'm going to do is I'm going to bind that section list to my LLM, and that's going to be my planner. So what's cool here is the planner is going to take an input, reflect on it, and produce a list of sections based upon its reflection. So this is dynamic. I don't know how many sections it'll create a priori. That's why this is a very good Orchestrator-Worker use case. Now in LangGraph, just like before, I create my state. Now in this case, what I'm going to do is I'm going to create a state for my orchestrator graph, which is going to have like a topic from a user, a list of sections, a list of completed sections, which the workers will all write to, and a final report. Okay, so that's state one. Now this is where things get interesting with Orchestrator-Worker workflows. In LangGraph, the way we often like to do it is for the workers, give them their own state. So why is this? Because each of those workers you want to handle independent inputs, and they're kind of all self-contained objects. Think about them as their own little buckets in which work's being done, and different work's being done in each one, but they're all writing out to the same output. And this is why I include this completed sections key in the worker state and in the graph state. So what's interesting in LangGraph is when you have overlapping keys and you write to, for example, this completed sections key in each worker, the outer state will also have that update reflected. So what's going to happen is all the workers are going to write to this completed sections key in parallel, and we structure this key with an annotation that allows for the addition of new elements. So that's really all we need to do. So here I'm going to create an orchestrator, and this is basically going to be my planner. I'm going to invoke it with the input topic from the user, and I'm going to tell it to create a plan. Then I'm going to have this LLM call, which is my worker. It takes in the worker state, and it basically says write a report section. And that's all I need. And I just pass it the section name and section description. And this completed sections is a state key that all the workers can write to in parallel. That's the key point. And all those sections are going to be accumulated in that completed sections key. Then I'm going to have a synthesizer that's going to read out the completed sections and just write them all out as a string. That's it. Write that to the final report key in my state. Now, this is the only thing that's new and a little bit special in Orchestrator-Worker style workflows. Because this is so common, we have a special API called Send in LangGraph that allows you to basically spawn these workers dynamically. And what's happening is, remember, my planner wrote the sections of the report to the state, and I can iterate through those sections. And I can basically assign each section to an independent worker just like this. For each section in sections, send to LLM call, that's my worker, and basically initialize the state as section when I do that. So then that LLM call, you can see, receives worker state, and it's receiving from state the section name and description. And then it goes and writes that section. It writes it output to completed sections, which my orchestrator has access to, and then the synthesizer basically just grabs completed sections and combines them. That's it. You're done. That's all you need to do. Now I can build this workflow, and there we go. So this dotted line just shows you that you use the Send API to spawn a whole bunch of LLM call workers. You don't know how many ahead of time. That's why it doesn't draw out each one specifically. It's going to be dynamically determined based upon the orchestrator's plan. That's the key characteristic of these Orchestrator-Worker workflows. You don't know a priori how many workers you need. The LLM will determine that on the fly. Now, let's show an example of this. I want a report on LLM scaling logs. So what's kind of cool is this runs fairly quickly. You can see the planner generated all these report sections. Great. And I can look at the final report and it concatenates them all together. And you can see I get this rich introduction, and then I get, fundamentals of scaling relationships following the plan. Now, in reality, when I do this, I have much more detailed prompts than I showed here. This is really showing you the workflow rather than the particulars of how I build a high quality report writer. In fact, I have separate videos on report writing you could check out, but this is just showing you how to set up an Orchestrator-Worker style of workflow. And we just talked about the Orchestrator-Worker workflow. Let's talk about something that's a bit related, the Evaluator-Optimizer workflow. In both these cases, you're going to have LLMs directing the control flow through predefined code paths. We have one LLM generate a response and another kind of grade it and give feedback in a loop. Now, I've used this quite a bit. For example, grading responses from a RAG system for hallucinations or for factual accuracy. I've used these kind of evaluator gates. And if, for example, there's hallucination in the output that isn't grounded by the documents, I send it back and have a regenerate response. And here, I'm going to use structured outputs again. You see, there's kind of a trend here. Structured outputs is like kind of all you need, in quotes. It's extremely convenient because you can really build all these workflows just with structured outputs. You don't have to use tool calling. For example, you can use routers to basically conditionally determine where to go next. You can have then nodes that, for example, just call tools depending on the result of the router itself. So really just structured outputs is a nice way that you can build a lot of complex workflows. In this case, I'm going to create a structured output. That's basically my grader model. That's going to be grade and feedback. Decide if the joke is funny or not in my case. And if it is not funny, give some feedback. Okay, so that's going to be my evaluator. And again, I'm going to find the graph state. In this case, I'm going to take a joke based upon a topic from a user. I'll generate the joke, and then I'll grade it. Give it feedback, determine if it's funny or not. Based on the feedback, I'll go back, regenerate a new joke. That's it. Nice and simple. So this is going to be my generator. It's going to generate a joke. Now, you'll see something kind of interesting here. I'm going to check if there's feedback in the state, okay? Now, there might be because I've basically looped back to this node if I determine that the joke is not good. So there may be feedback in the state. If there's feedback, I include it in my prompt. Otherwise, I just say write a joke about the topic. So nice and easy. And then I have an evaluator that basically takes in the joke from state and grades it. Again, this evaluator has structured output, so it'll basically produce a grade and some feedback. And then I have an additional edge that'll look at state, funny or not. So again, that's like kind of my grade. And if it's funny, route to accepted. If it's not funny, route to rejected in feedback. So again, this is the conditional edge I use to determine where to go next, just like we saw with routing. Build my graph, and you can see it has everything we want here. Here's the generator. Here is the evaluator. Based on the evaluator, we either go back, and again, you can see we set that conditional edge up right here. So that route joke conditional edge, we just talked about it. If funny or not, if it's funny, we go to accepted. So if accepted, we go to end. If it is rejected in feedback, we go back to LLM call generate. So you can see when you set up the conditional edge, this is how you can basically route from the output of your logic, your edge logic, to the next node to go to. That's it. It's extremely simple. And you can see, get a nice visualization of it. So let's give this a shot. Run it with an input of cats. So we get the output of the joke, and we actually can look at the state to see what the feedback was. So state feedback, in this case, it seems to like it, and let's check funny or not. And it determines it's funny. Okay, so our grader liked the joke. We went ahead and returned it then to the user, and we ended. And so we can see that the grader was initiated and decided to like the joke, so it passes, and we finish. So we talked about a number of different workflows that use LLMs within some kind of reasoning scaffolding. And in the case of Orchestrator-Worker, Evaluator-Optimizer, routing, you actually do let the LLM make decisions to route the control flow through that scaffolding. Now, let's remove the scaffolding, and let's talk about agents. With agents, you're simply allowing an LLM to form actions in the form of tool calls and directly receive the output or feedback from those actions. And so in the workflow case we talked about, there are always kind of these predefined code paths that we had an LLM kind of follow and kind of route through. In the case of an agent, we've removed those. Now, when do you actually need an agent? This is kind of the big question. You see agents being used in cases where you really have open-ended problems that you cannot easily capture in a workflow. For example, you want LLM to utilize different tools in a pattern that you just cannot predict a priori. So it's not easy to land in a workflow. So it's kind of open-ended task. We have some really interesting examples of challenges like SWE-bench, so a benchmark for software engineering, in which Anthropic actually used a agent architecture just shown like this, and achieved very strong performance. So we know for certain open-ended tasks, agents are appropriate. I do want to caveat, in the event that LLMs get extremely proficient at tool calling, it's also possible that a lot of the scaffolding that we talked about with various workflows is unnecessary. today, if you know roughly the sequence tools need to be initiated, it's often better to just capture it in a workflow in terms of reliability than just give it to an agent, let the agent hopefully call that correct sequence. Now let's just set up an LLM with tools. I'm going to give it multiply, add, and divide. Nice and simple. Now I'm going to define 3 nodes. So I'm going to call my LLM, and I'm going to basically allow the LLM to call a tool. Okay, so I'm using my LLM with tools. And in this particular case, I'm saying you're a helpful assistant tasked with performing arithmetic. So the output of that tool call is going to be saved to this messages key in our state. So what's happening is my state has a single key, in this particular case, messages, which is going to accumulate what I pass as the user, what the LM produces, and so forth. So what's going to happen is I have another node called tool node. It's going to look at the state, look at the last message, determine if it's a tool call. If it is, it'll go ahead and just call that tool. That's it. Nice and simple. And it's going to return that to state. So what's interesting here is I'm going to have a sequence of human input, model agent in this case, decides to call a tool. This tool node looks and sees, oh, the LM decided to call a tool. It actually runs that tool call. That then is written to state messages as a tool message. This is that environmental feedback thing you hear about. So you talk about agents, they can perform actions. That's the tool call done up here. Fine. They also can receive feedback from the environment and act on it. That is the output of this tool node. This tool node is basically the environmental feedback saying, here's the output of the tool call. The LLM then will get that, decide what to do next. That's it. That's an agent. Now, the only other thing I need is this conditional edge that basically says, was the last message a tool call? If so, I'm going to go ahead and route to the tool node. And if not, I will end. So, you can modify this in different ways, but a lot of times people basically just say, allow the agent to continue making tool calls until it decides it doesn't need one anymore. And then you're done. So there we are. I mean, that's our agent loop. And that's kind of why agents are elegant. They're extremely simple in this kind of formulation. All it is, it's basically an LLM initially with a bunch of tools. And it's like a tool node that will run the tool for you and return that environmental feedback to the LLM and let the LLM keep spinning until it decides you don't need a tool call anymore, then you're done. That's really it. Now, again, this tool call thing, think about that as actions. So this LLM can perform actions. The actions are determined by the user. So you can pass in any set of tools to this LLM. It decides to perform those actions. Now you need some system that actually does those actions. So that's what we create with this tool node. And this just loops until the LLM says, I don't need a tool call anymore. And then that conditional edge says, oh, okay, I can just end. That's really it. So let's see an example of that. I'm going to basically tell this agent, add 3 and 4, then take the output and multiply by 4. Okay. Now look, this is extremely simple. An LLM can just do this. I totally get it. This is more showing you the principle of setting up an agent with these tools for addition and multiplication and testing whether or not it can correctly perform these tool calls in sequence and looking at the flow of messages. So here we go. This is pretty cool. Now, again, this is like a toy example, but that's showing you the flow, and that's what matters. You have an input from the human, my instructions. The LLM looks at that and says, okay, I need to make a tool call. Makes a tool call. The tool node executes the tool call, returns environmental feedback to my LLM as the result of the tool call, which is 7. My agent thinks about it, makes another tool call, responds with 28. Agent thinks about it. Final result is 28. Here's how we got there. No more tool calls needed. Done. For all the hype of agents, that's all it is. Extremely simple. It's tool calling in a loop. Now, again, why don't we just do this? Because, look, a lot of problems can be solved with workflows, which are a bit simpler. Agents haven't been particularly reliable to date, particularly with large numbers of tools or complex trajectories of tool calls. And so a lot of people actually in production prefer workflows. I've done a lot more workflows than agents, to be honest, over the last year or two. But I completely acknowledge in the event that you have very capacity reasoning models that can perform low latency, high quality tool calling, and we have more kind of confidence that they can perform reliably in production, I think you will see the movement to this classic style of very simple tool calling agent in production. But the game in the field today is a little bit more like people are saying, well, I want to put workflows into production because they're a little bit more trustworthy. Again, I have some scaffolding around the core kind of LLM calls. Now, I do also want to show, this is looking at the documentation, that we do have a pre-built method called create React agent that basically wraps what we just built from scratch right here for convenience. Now, this depends if you want to build it from scratch yourself, just as we did, that is completely fine. If you want to use the pre-built method, that's fine as well, but it's available to you. And I will be sharing the link to this tutorial page, which has everything we just went through. So all the different workflows we talked through are all in this tutorial, which I will be sharing. But just from this little tutorial, you've seen, here's how you can lay out all these different workflows and an agent all in LangGraph. If I go back to the why LangGraph story, what you get with LangGraph is when you compile those workflows or agent in LangGraph, you're getting a persistence layer for free, which gives you short and long-term memory. And that also gives you the ability to stop, perform interruptions, review, and continue, i.e. human in the loop. It gives you a whole bunch of streaming capacities. You can stream independent values from your state at any point in time. You can stream, of course, tokens out of LLM calls, and you also get deployment. So we have a very nice and easy on-ramp for testing, debugging, and deploying any of these. So you could take any of those workflows or agents we just built and deploy them in like 5 minutes. So very, very quickly. That's really what you're getting with the framework. And you can also see with LangGraph, it's pretty easy to lay them out. And we're actually working on making it even easier. So we're trying to reduce the overhead so you can lay it out almost as if you're writing Python. You're not even thinking about the framework, but you're getting these benefits kind of for free when you do use the framework. That's kind of the big idea here. So hopefully this was a helpful overview to present how to lay these various workflows or agents out using LangGraph and what benefits you may get from LangGraph as a consideration. So thanks very much. Feel free to leave any comments below.